Okay, in the following 6 videos we're going to look at chemical bonding, and in particular we're going to look at primary bonds. I'll explain a little bit more what they are in a second. Let's get into it. So as usual we have our science understanding here on the left, and that goes through what the subject outline for stage 1 chemistry tells us that we need to know. So use that as a bit of a checklist as we go through this, that you're understanding the concepts. So firstly, in this first video we're really just going to do a bit of an introduction to bonding. And as I said before, we're going to look at primary bonds. And primary bonds fall into 3 general categories. They are metallic bonds between metal atoms, ionic bonds between metal and non-metal atoms, and covalent bonds between non-metal and non-metal atoms. And we're going to look at 2 different types of covalent bonds. Molecular covalent bonds, which is where we have a small group of non-metal atoms bonded together, and continuous covalent compounds where we have large networks of non-metal atoms. These have some quite different properties, that's why we'll consider those separately. The reason we use the term primary bonds is there's also something called secondary bonds, and these exist between molecules in our molecular covalent compounds, and also sometimes between ions and molecules as well. We're going to do a lot more on that later on, and that's going to form the basis of a lot of what we do in our first practical investigation this year. So we'll cover that in a later series of videos. We need to link these type of bonding to the properties, in particular the physical properties that we see in various materials. So some of those properties we're interested in are melting point, which is at the temperature a substance melts to form a liquid; electrical conductivity, which is the ability to conduct electricity, which is basically can charge particles, which can be either ions or electrons, move through the substance, because electricity is a flow of charge, so we need to have charged particles able to move for something to conduct electricity. Is it malleable, which is the ability to press something into shape? Is it ductile, which is the ability for something to be drawn out into wire? And these 2 things go really together, mostly when we're talking about metals. We're interested in whether something is brittle, so its brittleness, which is basically when you try and deform it through bending it or squashing it or hitting it, does it break, as opposed to bending or moulding into shape if something is malleable. So what makes things brittle? We're also interested in hardness, which is the resistance to deformation. So if you push really hard on something, does it change its shape, or is it very hard and not able to change its shape? Now, the whole basis of nearly all bonding is that atoms generally bond to achieve full or empty outer or valence shells. The holy grail of atomic happiness, as I like to think of it. So nearly everything we see in both metallic, ionic and covalent bonding is going to relate to atoms trying to achieve full or empty outer shells. In a similar way is to when we looked at ions in a previous video, that things usually form ions to again achieve a full or empty valence shell. Whereas the subject outline likes to say stable valence shell configurations. Basically a full or an empty outer shell. Okay, thank you.